Okay, I know it's June, and maybe you're not thinking about Valentine's Day, but let's say it's Valentine's Day, or your anniversary's come up, and you're feeling quite the man, or maybe your man likes heart balloons. I don't know, whatever. Anyway, yeah, it's not June anymore. We'll say, for the sake of our little example here, and you go out and you buy a heart balloon to commemorate your love with your sweetheart, and you live in Alaska. Okay, in Alaska. Come on now. In Alaska, it can get really cold. Okay, and let's say that inside the store, it's it's a nice 25 degrees Celsius inside the store, and that the temperature of the balloon that you just bought was 25 degrees, just like the ambient temperature around the room. Okay, now because I was born in Utah, well, or United States more properly, I need to do a conversion because I can't think of cold in my head without doing it in Fahrenheit. It's an unfortunate thing, but it's I hope something that goes away. So if I look at, let's say it's 40 below Fahrenheit, and that's not what I wanted. Yes, okay, that's better. All right. Did I spell it wrong? What's going on here? Okay. What? Really? That seems awfully fishy to me. Well, that's boring. Okay, let's say it's 60 below. That's more exciting. Okay. So, here I am, and I just walk out of the store, and it's negative 51. Don't you know I picked the one that matches? That's ridiculous. Okay, here we go. Negative 51 degrees Celsius, right? Okay, I meant to do that on a different layer, but I'll just have to deal with it for now. All right, well, assuming that the gas inside of this, and it doesn't really matter what the gas is, okay? Let's put my gas in there, okay? What is going to happen when I go outside to walk home with this balloon for my sweetheart when it starts to acclimate outside? That's what I want to figure out. Well, it's not that hard of a problem, really. Let's just, your problems are just about to start happening when she thinks you forgot. Okay, well, what we know is that you could take the volume over the temperature, or let's derive this first, okay? This is Charles' law, right? I say that the volume is equal to some constant times the temperature, and so I can say that for that volume, and I'm talking about the first one for right now, that the volume is over the temperature is going to be equal to some constant, and that's going to be equal to whatever I do to mix up the other two. Okay, like that. Okay, assuming that we don't, change things like how much helium there actually is in the balloon. So we'll just say it's helium because, why wouldn't you? Okay, maybe this was a tricky example. I don't know how this is going to turn out because is that enough of a difference? We'll see. We'll see. Now, the first thing that I should look at here is with temperature in the denominator, I don't really want to get to a 0, right? Now, it's not going to affect me here, but in problems like this, you're probably gonna want to convert to Kelvin, because if you don't, you could end up with a 0 in the denominator, and instead of your balloon, all hell freezes over because you can't divide by 0. So here we go. The first volume. Oh, I didn't give you a volume. Let's say it's a 500 milliliter balloon. Okay, what is its volume going to be now? Okay, well, let's find that out. And we could use any units we want here. It doesn't really matter. I just chose an arbitrary one, i.e. And I'm writing backwards again. Milliliters. Okay, so I have 500 milliliters. Okay, and the temperature I want in Kelvin. So I'm going to say 25 plus 273.15, right? That's just one you have to memorize. Lots of strings of numbers I've been memorizing lately, I'll tell you what, and that's kind of a pain. Now, just so I don't mess up, sometimes I'll even do my calculations just straight out, even though I know the answer. 25, 273.15, 273.15, and I add them together, that gives me 298.15, okay? So, divided by 298.15 Kelvin, and that's going to be equal to volume 2 we don't know yet, but we do know the temperature, and that's going to be, I'm not going to write it out this time, let's just do 51, okay. And it's negative, right? And we're going to add 273 to that, and that will give us 222.15, okay? Now it's easy, right? So I take 222.15 times 500 milliliters divided by 298.15. All right. And that gives us a volume of the new balloon of 300, or significant figures here. It looks like it gave, well, here, let's do this. What's more interesting? Can't do that on a real report, right? Okay, so I'm going to say 373 milliliters. Okay, now just for kicks, let's just figure out what a percentage size decrease that would be in our balloon. So I'm just going to go 500 milliliters here was the original size, and divide it. So the balloon is going to be 74% of its original size. And boy, won't you be embarrassed. Okay, so let me do that. Here we go. I can lock this. See, this is the power of Photoshop. 75%. So make sure, if it's you, that you fill up your balloon better. Or no, don't fill it up better. That'd be worse. It could pop when it gets inside. Just let it warm up before you hand it off, maybe, and you'll be good. So that is Charles' law, and that's how temperature can affect the pressure of the gas ultimately, because you know, there's less movement around. You're slowing the molecules inside it down a little bit, and they're not hitting on the outside walls of that balloon as much as they would be when it was warmer inside the store where you bought your cute little balloon. Thanks. Bye.